In this video, we're going to talk about the types and numbers of solutions to quadratic equations. We can actually learn a lot from the discriminant of the quadratic formula. So here we have the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. The piece underneath the radical, that b squared minus 4ac, is what we call the discriminant. And this discriminant can tell us whether or not we have real solutions or imaginary solutions, and whether or not they're going to be rational or irrational. We get all that information here from this discriminant. And the reason that that works is because the piece under the radical, since it is a square root, we can automatically tell whether or not something will be real or imaginary if this number ends up being positive or negative, right? So if I have the square root of a positive number, I'm going to have two real solutions because I'll have plus that square root and minus that square root. If I have a negative number underneath the radical, we know we can't take the square root of a negative number and get a real solution. We will get a complex or imaginary solution. So if this number ends up negative, it'll be complex. And we'll still have plus that square root of a complex and then minus that square root. So there'll still be two solutions, and they'll be complex if that number is negative. If this is 0, well then the square root of 0 is just 0. So this would be gone, and we'd have plus and minus 0, which is the same whether it's plus or minus, so there'd only be one solution. So if it's positive, it'll be real. If it's 0, there'll only be one real solution. And if it's negative, it'll be imaginary, and there'll be two. If the number underneath the radical is a perfect square, we can take the square root of a perfect square, and we'll end up with a whole number. And then we'll have plus or minus this whole number, and we'll end up with a rational solution. So whether or not it's positive or negative, if that is a perfect square, it'll be rational. If it ends up being not a perfect square, then we'll have the square root of a non-perfect square, which the square root of anything that's not a perfect square is irrational. So that's why we have this column here. Is it a perfect square? It's rational. If it's not a perfect square, it'll be irrational. So positive is real. 0, there's only one rational. Negative, it's complex. Perfect square, it's rational. Not a perfect square, it's irrational. So it all comes down to that square root and what are we taking the square root of. Alright, so this first problem says determine the number and type of solutions. It's in standard form, so we can pull out A, B, and C. A is 1, B is 9, and C is negative 8. And we do not have to solve. Okay, it does not ask us to solve it. It just says determine the number and type of solutions. All we need to use is the discriminant, b squared minus 4ac. That's all we need to know. So filling in what we just found for a, b, and c, 9 squared minus 4 times a times c. 9 squared is 81. Negative 4 times 1 times negative 8 will be a positive 32. And 81 plus 32 is 113. So I can see that this is a positive number, and it's not a perfect square. Since it's positive, there will be two real solutions, and they will be irrational because it's not a perfect square. So positive means two real, not a perfect square means irrational. And that's the number and type of solutions. Let's look at the one below. This is not in standard form. It's not set equal to 0. So I have to subtract 4x from both sides to get it in that standard form, and we'll have x squared minus 4x plus 4 equals 0. Now it's in standard form, meaning a is 1, b is negative 4, and c is positive 4. We filled into our discriminant, so b squared minus 4 times a times c. Negative 4 times negative 4 is 16. 4 times 1 times 4 is also 16. And 16 minus 16 is 0. That means that when we solve this, that whole square root is 0. And square root of 0 is 0, and this piece would be gone. And we just have b over 2a. So there's only going to be one real, and since there's no radical, it'll be rational. It'll be some form of fraction or whole number solution. Because when it's 0, there is plus and minus nothing. So there can only be one real rational solution. I would like you to try the 3 on the right-hand side. Okay, first example on the right. 4x squared plus 9 equals 0. That's in standard form. We can identify a is 4. And what is b? Well, there was no x term, so b is 0. And c is the constant, which is 9. We plug it into our discriminant, 0 squared minus 4ac, and 0 is just 0, so we'll end up with negative 4 times 9 is 144. This is a negative number and a perfect square. So since it's negative, there will be two complex or imaginary and rational solutions. Because of that perfect square, that we'll be able to take the square root of a perfect square, and it will end up rational. So two complex but rational solutions. Alright, in the next example, this is not in standard form, so I need to get everything on one side. I'm going to subtract 2x, subtract 2x, add 3, add 3. This gives us 5x squared minus 2x plus 3 equals 0. That means that a is 5, b is negative 2, and c is 3. Filling it in, b squared minus 4 times a times c. Negative 2 times negative 2 is positive 4. And 4 times 5 times 3 is 60. So we end up with negative 56. Now, that is negative, but it's not a perfect square. This means that it'll be 2, so the negative number means 2 complex, and in this case irrational, because it's not a perfect square, solutions. So again, that first number tells us it's 2 complex, and the part that's, or because it's not a perfect square, it tells us it's irrational. Lastly, this problem is already in standard form. We identify a as 4, b is negative 2, and c is negative 2. We fill it in. B squared minus 4 times A times C. Negative 2 times negative 2 is positive 4. And negative 4 times negative 2 is a positive 32, which gives us 36. It's a positive number. It's a perfect square. That means there will be 2 real and rational solutions. The only time you get one solution is if it's 0. So positive means 2 real. Perfect square means it's rational. And there you have it. So I would not try to memorize this table. I would think about what does that number do, or how does it affect that radical? So it all comes back to taking a square root. Are you taking the square root of something positive or negative or 0? And is that number a perfect square or not?